It's actually so good. It was like a half past response.
Yeah, I was doing like I'm also trying for like I was like, wow, okay. Sorry that I'm not like really
Not like the snow today.
What did you think of the one was?
It wasn't that bad.
How your first one?
We'll see.
I'm so nervous because she's just gonna like
I thought it was good. It's just gonna butcher the points.
Right.
well,
The multiple choice was fine. It's in Google, but the rest, FRQs, we'll see.
it's not even that like he's such a harsh critic.
Jesus Christ. She's just trying to give us the AP grading experience, which I understand, but like when applied to grades, it's kind of
It hurts.
yeah, it's not nice.
Dawn probably got it.
Dawn's about to get a 31 out of 30. I'm like, how? I think last time he got the 30 out of 30 because he argued for the electoral college, which like no one else did. So I think he got a lot of points because the arguments were like, I don't know, easier. I don't know, Dawn's just OP. Oh. The music part.
What's your second? What was your second? Was it like the person is like going to school?
You didn't get practice for that.
Yeah, he didn't tell us like what.
She's doing the econ with
How much after.
It's not yet.
Oh, I got like a 75%.
Face or like after every three.
No base. I'll do test corrections and I'll end up with like 100.
Yeah.
I've never done test corrections before though. So I don't know how to do them. He's got it on the slide somewhere. So.
Well, isn't this econ test like mostly non-econ? Like not non-econ, but non-this.
Yeah, it is. So like,
This one was just
it was hard, dude. Like I don't know. But it's not hard as long as there's corrections.
Like I can only say so much about how this works on the working. The short-term and long-term memory. So what is the
Market failures. There's a lot of stuff about non-excludable and rivalrous stuff that I just did not understand. Like I don't understand excludable goods. They're weird. Excludable means that you have to pay for it to get it. Like for example, like if you live by a river and water is a resource, it's non-excludable because they can't make you pay for the water if you just live there.
Oh, I remember that.
Versus like a concert is excludable because you have to pay to get in. But you could say a concert's non-rivalrous if they have an infinite amount of tickets.
Oh, yeah, no, it's like
What if the concert's on a riverboat?
What? Well, the river would be non-excludable, but the concert would also probably be non-excludable. Like the ones that are hill are non-excludable. You just go. They're not gonna like make you pay. Econ is weird. Washington's nice, so that's fine.
Alrighty. Hello, everybody. Welcome. want to say hi to the folks at home? Folks at home, do you want to say hi to the folks in the classroom?
Hello.
Thanks, Isaac. Alrighty. So as we get started, a quick check-in for us this afternoon. It's a return to the mood meter. We've used it before. We're using it a little bit differently this time around. Got some practice questions for you around, I'm hoping you had a chance to watch the Edpuzzle video on enzyme structure and function. An enzyme is a special category of proteins. So we've been looking at protein structure and function for these last few class periods. So I've got an online activity where you can check your understanding of enzyme structure and function, and then some practice questions from released AP exams that you can use, again, to check your understanding. Of course, we can go over any of those if you want to. And then the second half of class, whether you're at home or here in the classroom, I've got a lab experience for you on an enzyme catalyzed reaction. So we'll get started in those two different spaces together when we get there. What questions do you have for me or for the group? Oh, are you in student mode here? Better? Sorry. Didn't change it from last class. All right. So our check-in again is using the mood meter. There's 2 dots to drag this afternoon. The orange dot, let's take a moment now. Notice how it is that you're feeling. Let's give it a name. Drag the orange dot to the word, the color, the quadrant that best represents how you're feeling right now. And then when you're ready, we have a break coming up, right? We have a break coming up. We're all gonna take a break.
Yes.
There's no homework over break.
No.
There's no reading.
No.
There's no tests. There's no school. So the second dot is a heart. If you were to put yourself back into school on January 5th, which is when everybody comes back, how would you like to feel on January 5th? Can you drag the heart to the word, the color, the quadrant that best represents how you want to feel? Let's see, you are the 7th class to do this. I've been collecting results over these last 2 days. Look at the difference. Where you are, where you want to be, where you'd like to be. So there's no spot to write this next step down. It's going to happen inside. How can you get there? What can you do over these next 2.5 weeks to help you get to how you want to feel? Just take a moment, think about what you might do differently or new. So before we move into the biology, I wanted to share a strategy that you might find useful. And it's something that, I wish someone had shared with me back when I was your age, in the 90s, not the 1890s. It's the power of no. No is a complete sentence. No, it's not. It doesn't have a subject, doesn't have a verb. They're implied. No, I'm not going to do this. No, I'm not going to take part in that. No, I'm choosing to do this differently this time. You always have permission to say no. So I invite you to play around with that. Maybe you'll find it useful, maybe you won't. I know that I'm finding it useful at this point in my life. So, thank you for sharing. I'm gonna go ahead and let you drive the slides here. Let me know if this messes you up though. You still on the agenda? Or are you all the way at the beginning again? At the beginning? Okay. So now you're back at the agenda. You click on the links to the activities. You test it real quick, let me know. Like the enzyme penny machine, if you click on the link, does it work? It does? Okay, so that's where I would recommend that you start as a way to assess your understanding of what you watched in the video. And then when you're ready, you can move on to the practice multiple choice questions. Let's take maybe about 6 minutes. We'll come back together at 12:17 and see if there's anything that you'd like to talk about as a larger group. You have a chance to answer both questions? Try this one too. Yeah, okay. Sorry, it's because I think you're in teacher mode. If you haven't had a chance to answer the second question, give yourself an opportunity to do that too. We can come back together and chat if that would be helpful. Trying to monitor the submissions here. Is this a good time to come back together? Have you had a chance to look at both questions? Or do you need some more time? I'm doing my best to monitor. You okay? Okay, thank you. All right, would it be helpful to look at the multiple choice questions or look at anything from the interactive activity? Which ones? Multiple choice? Okay. One of them, both of them? I'm hearing both. Okay, not a problem. So I like the first question because it connects where we were to where we're going. You've got a single polypeptide. Remember that polypeptides fold into proteins, the three-dimensional form of the molecule. And we're told that there is a substitution of serine by phenylalanines. We're swapping a polar amino acid out for a non-polar amino acid. Remember, R group is just short for side group. And researchers test the catalysis of the normal enzyme and the mutated enzyme doesn't work. Which of the following explains the substitution and how it affects the catalytic activity of the enzyme? So remember, enzymes are just special classes of proteins. So if we've altered, in this case, the primary structure of the polypeptide, right? We've altered the composition of amino acids in the polypeptide, we might very well expect there to be a change in the way that polypeptide folds into a protein. Okay. Oops, sorry, wrong button. So let's see what you came up with. Yeah, overwhelmingly, this is not just your class, this is everybody, right? That the substitution in that one for that one amino acid has altered. Here it's written the secondary and tertiary. It's most likely the tertiary, but that's okay. But regardless, we've altered the tertiary structure, the three-dimensional structure of the enzyme, and now the enzyme just doesn't work like it used to. Okay, we've altered the structure, we alter the function of the molecule. All right. Does that help? Okay, no one's screaming at me. Second one, 4 graphs. We're told each graph represents a different hydrolytic enzyme. So this would be an enzyme like the one in the Edpuzzle video. I think I paused it and said, in this half of the image, what's happening? And in this half of the image, what's happening? And one of them was hydrolysis and one of them was dehydration synthesis. So we're focusing on 4 different hydrolytic enzymes, but in reality, we're just looking at one because we're asked to consider what's happening in graph 1. Activity of the enzyme versus pH. Looks like at lower pH values, there's virtually no activity for this enzyme. At higher pH values, there's virtually no activity for this enzyme. And I don't know, somewhere around pH 7-ish, the activity has its maximum effectiveness. So in the second half of the Edpuzzle video, the Amoeba Sisters introduced you to this concept of denaturation, where in certain extreme environments, often temperature, high temperature or low temperature environments, or high pH or high low pH environments, the physical structure of the enzyme will change. It will become denatured. And if those situations are extreme enough, the protein shape can change in a way that the enzyme becomes non-functional. That's what we're seeing out here at pH 5 and at pH 10. Right? The enzyme isn't working anymore. Its activity is 0. Now at In this case, for this enzyme, at more moderate pH values, right, around pH 7, heck, even pH 6 and pH 8, the structure of the enzyme hasn't changed, right? And as a consequence, it's still working. So as we look at our answer choices, let's see how you did. Yeah, we expect that the most likely explanation, right, is that the pH has affected the active site of the enzyme. Recall from the video that the active site is the spot, the crest, the crevice on the enzyme, the part of the enzyme to which the substrate binds and where the reaction will take place. Heck, it's where the products are formed. So if the pH has affected the structure of the active site, the spot at which the reaction takes place, well, then the enzyme isn't going to work anymore. Its activity drops to 0, or at least is less than maximum. What questions is this bringing up for you? Well done. Let's transition. And here's what I'm going to ask folks to do. If you are here in the classroom, if you could go find a lab station to work at. You could bring your device, but I'll have what you need up here on the smart board. So I'll leave it up to you to decide if you want to bring your device or not. So go make yourselves comfortable. Folks at home, I'm going to get you started, and then I'll switch. All right. So you can either click on the link to the virtual lab, or it's on Google Classroom too. It's lab number 9. And what this is going to take you to is what I would recommend actually first is that you watch the video that I made on how to use the software and how to use the website to run this virtual experiment. It's about 6 minutes long. And then really your goal for the time that we have left today in class is to use that website, use that simulation to come up with a set of conditions that would serve as a negative control. So recall that a negative control is the part of your experimental setup where you do not expect there to be a change in the dependent variable. So hopefully as you learn about how the software works, you can play with the software and get to a point where the reaction isn't happening. And as a consequence, there's nothing to be measured. There's no change in the dependent variable. That's about as far as we're going to get today. Okay, we'll come back and do the next part, the positive control and the experimental work on Friday. Okay. So start with the video. I'm going to put the microphone on mute, but the speaker here in the classroom is still on. So if you need me for any reason, just yell and I'll come back to the computer. All right, if we could come back together just for a moment before the bell rings. So success with your negative control, I hope, whether you're at home or here in the classroom. Next time, we'll do our positive control, so that reaction will have enzyme. And then you're going to have a choice, whether you're at home or here in the classroom, to choose a variable that you think is going to influence the rate of this enzyme catalyzed reaction. So you might choose pH. You might choose the concentration of enzyme. You might choose the concentration of substrate. There's lots of different options available to you. You get to choose. And hopefully you'll have, since these trials are short, you'll have some time to collect data around one of those variables to see how it affects the rate of the enzyme catalyzed reaction. Okay. So negative control was today. Friday will be positive control and experimental variable. Okay. That'll be our last in-person day for a while. So our remote day next week will be an opportunity for everyone to work on the lab write-up. I'm trying to keep it really short and concise so that there's no homework over break, there's no homework over the weekend, anything like that. We really, I don't know about you folks, but I need to disconnect from this place for a while. So my hope is that we can wrap that up in the, 50 minutes that we have on Tuesday, and then we'll be good to go. All right? What questions do you have? Okay. I think then everything else, we are good to go until next time. Yep, because you folks did a really nice job collecting data quickly and cleaning up quickly. So folks at home, you are welcome to sign off if you'd like. We will meet again on Friday. And folks here in the classroom, you can close up your electronics, I'll spray off, and you can leave a minute or two early. Avoid the private hallways. Private hallways.
Yeah, can we just do one FRQ unit?
Thank you.